Hey guys, so 3.3, we are going to divide polynomials. So instead of doing the exploration that's on this page, I just want to remind you of how to do long division with numbers and not letters yet, not variables. So if you remember in elementary school, we would have something like 8,347 divided by 5. Okay, and to do long division, we would put 8,347 underneath and 5 on the outside. Then we would do little things that say, how many times does 5 go into 8? And you would say, oh, it goes in there once. And then I would multiply. 5 times 1 is 5. Then I would subtract. So I get 3. And then we would bring down the next number. We do those steps over and over again. So how many 5s go into 33? Well, 6, because 5 times 6 is 30. And then we subtract 3, bring down the 4, all the way down. How many 5s go in 34? 6, because 6 times 5 is 30. Subtract 4, bring down the 7. How many 5s go into 47? 9. Then we get 45 minus, and we get remainder 2. Now, when we were younger learning division, we would just put R2 for remainder 2. But then as we got more sophisticated in our mathematics, we started to put that as 2 over what we were dividing by. So 1,669 and 2/5. Okay, that was our steps for long division. What we're actually going to use are those steps right now to divide polynomials. So in this section, we are going to do long division with polynomials. I'm going to teach you a nice tricky way with synthetic division. And then we're also going to use the remainder theorem that allows us to know if it's a factor or not. Okay, so long division of polynomials. When we divide a polynomial of f of x by a non-zero polynomial of the divisor, so the divisor is what we're dividing by, you get a quotient. Okay, a quotient is that q of x. And then with that quotient, we get the remainder. Okay, now if it is factored, if it's a factored polynomial or a factor of that polynomial, that remainder would be 0. And we'll come into more of a flow with that later. The degree of the remainder must be less than the degree of the divisor. When the remainder is 0, the divisor divides evenly into the dividend. Also, the degree of the divisor is less than or equal to the degree of the dividend. One way to divide polynomials is called polynomial long division. So what that really means is, think about the problem we were just on. The remainder, in this case 2, had to be smaller than the divisor, which is 5. Okay, so when we talk about polynomials, you're talking about the degree of that polynomial has to be smaller. Okay. So here we're dividing a 2x to the 4th plus 3x cubed minus 5x minus 1, or plus 5x minus 1, by x squared plus 3x plus 2. So what happens is our dividend, our function that we're focusing on, is 2x to the 4th plus 3x cubed plus 5x minus 1. And we're dividing that by the divisor, and we put that on the outside of x squared plus 3x plus 2. Okay, now see what I just wrote down? I hope you wrote in pencil like I did, because I forgot something. With polynomials, you must have each term. So as you can see, I have x to the 4th, x to the 3rd, but what am I missing? I'm missing x squared. So I have to erase that, and I actually have to identify that as plus 0x squared, because it wasn't there. And then I go back to my plus 5x minus 1. You want to have each of the terms there because it makes it easier when lining up, okay? Now, first thing I'm going to do is just look at my x squared and my 2x to the 4th. Now, on the numbers, we were saying, well, how many goes into how many? The other way to think about this is, what do I multiply x squared by to get to 2x to the 4th? Well, to get there to be a 2, I would have to have a 2, because 2 times 1 is 2. And x squared times x squared is x to the 4th. So x squared times 2x squared is 2x to the 4th. You want these two terms to equal. Okay? Now, we have to multiply each term by x, 2x squared. 2x squared times 3x is a positive 6x to the 3rd. X times x squared is x to the 3rd. 2x squared times 2, well, 2 times 2 is 4, and x squared times 1 technically is x squared. See how they go in order, guys? Now, the worst thing about long division is the subtraction. Okay, so be careful. We're going to subtract straight down. So as you can see, 2x to the 4th cancels with 2x to the 4th. 3 minus 6. 3 minus 6 is negative 3. And then we're keeping our x cubes because the exponents don't change when we're adding or subtracting. 0 minus 4 is negative 4. And then we bring down, just like we did earlier, the 5x. I'm going to show you another trick in a minute if you did not like this subtraction. Okay? Now we start over again. What do you multiply x squared by to get to negative 3x? Well, 1 times negative 3 is negative 3, and x squared times x is x cubed. And look, we're just going down by 1. Okay, so keep that in mind. Now we're going to multiply by each. Okay, negative 3x times x squared is negative 3x cubed. Negative 3 and positive 3 is a negative 9. X times x is x squared. Negative 3 times 2 is negative 6. And then x times 1 is x. So see how everything's lining up? Okay, remember I told you I was going to show you this trick. So if we minus everything, what we could do is add the opposite sign. Remember, subtraction is adding the opposite. So if I change this to add, I have to change all my signs to the opposite, which in this case is addition, and it works out really nice. So those two cancel, right? Because you add them together, you get 0. Add these together, we get 5x squared plus 11x. Bring down the negative 1. Almost there, guys. What do you multiply x squared by to get to 5x squared? Well, the x squareds are the same, so all I have to do is multiply by 5. And then we've got to multiply every term again. So that's 5x squared plus 3x times 5 is 15x. And 5 times 2 is 10. So if I subtract and add the opposite, right? I would be adding. I would change that to subtraction. Change that to subtraction. Now if I add straight down, these cancel. Oops, that should be negative, right? These cancel. Add straight down and get negative 4x. Negative 1 and negative 10 is negative 11. This is my remainder. Now, if we go back up here and how we're supposed to write our quotient, we would write our top part first. So 2x squared minus 3x plus 5. And what we do is we add. The remainder goes on top, so negative 4x minus 11 all over the divisor. And what did we divide by? We divided by x squared plus 3x plus 2. Okay, that's a lot. So knowing that that's a lot, what I would like you to do is I want you to do number 2 on the monitoring progress. I want you to pause this video right now and do number 2, just like we did above. And then when you play, I'm going to go over this problem number 2. Okay. All right, hopefully you paused it so we can go through this. Hopefully I left myself some room. So the first thing I'm going to do, what do I multiply x squared by to get to x to the 4th? Multiply by x squared. And then multiply in x squared minus x cubed plus x squared. Oh, what did I do, guys? You see that? It's not lining up. I made a mistake. Plus 0x cubed, and what was it? Plus 2x squared minus x plus 5. So now you see, I'm glad I made that mistake because I see you guys making that a lot all the time. So see how they line up now? Okay, I'm going to subtract straight through, right? But I'm going to change the sign. So if I change this to addition, this becomes a negative, positive, negative. Sorry, that was x to the 4th. Subtract or add, those are 0. Add, don't forget this is 1 here, and that's a tricky problem, right? 0 plus 1 is 1. Add, we get 1x squared, bring down negative x. Okay, what do we multiply by x squared to get to x cubed? We multiply by an x. Multiply that in. So we get x cubed minus x squared plus x. Subtract. Instead, I'm going to add the opposites. These cancel. Remember, this is 1 and 1, so that's 2x squared minus 2x. Okay, so be careful right there. What do you multiply x squared to get to 2x squared? Well, we multiply that by 2. Forgot to bring down. 2 times negative x is negative 2x. 2 times 1 is 2. Minus, we're going to add the opposites. So I get 0. Ooh, I get 0 again here. And then I get 5 minus 2 is 3. So that's my remainder. Now remember what to do with your answer. So we have our quotient, which is x squared plus x plus 2 plus, and it's our remainder over our divisor, which is x squared minus x plus 1. Yay! Okay, let's move on. I like this way a lot better, I promise you. Okay, synthetic division. There's a shortcut for dividing polynomials. Yay! By binomials. But the thing is, guys, they have to be in the form x minus k. So if you have an x squared or an x cubed, you have to do long division. But if you have an x to the first, or really a 1x to the first, you can use synthetic division. So I'm going to show you how to do that now. Okay, so first of all, we have x to the first, so that's why we can use it. The idea is we're going to use the k value here. What I always think the fast way to do it is it's the opposite to what I see. So I see a -3, so I'm going to put a 3 right out front. Now what I'm going to write down is the coefficients in front. But just like on the other long division, you have to do it for every term. So we have this negative, which is -1 in front of the x cubed. We have a 4 in front of the x squared. X. We don't have any x's, so I need to put that 0 in. That's going to be your biggest mistake. And then we have a 9 for a constant. Everybody think you can do that? Okay. So this shows you it in steps. You could do it all in one piece if you wanted to. So right now we have this 3, -1, 4, 0, and 9. So this is how to do it. And of course, I could make this a little bit bigger so my arrows will line up. -4, 0, and 9. Okay. The first thing you're always going to do is bring down this first number. So this first number is -1. Then what you are going to do is you are going to multiply. Okay? So 3 times -1 is -3. The other thing that's great about synthetic division is that you're adding and not subtracting. And then you're going to add, see? Yay, adding. -4 plus negative, why did I put -4? Wow, guys. 4 plus -3 is a 1. Okay, you guys can continue doing it on that step, but I'm going to show you what happens. So right now we have this going on. We bring this down, we get -1. We multiply, we get -3, and then we add straight down and we get 1. Next, we repeat. Multiply, add, multiply, add. So I'm going to multiply 1 times 3 and get 3. I'm going to add straight down and I get 3. Multiply again. 3 times 3 is 9. Add straight down, you get 18. Okay, now here's the tricky part. This last number is always the remainder. And then what happens is we're going to go in order. Constant, x to the first, x squared. Okay, and we'll always go like that. So my final answer is going to be -x squared plus x plus 3 plus, remember we do the remainder over the divisor. Our divisor in this case was x minus 3. Okay, let's try it again. Ready? So remember, what's the k? The k is opposite to what we see. It's x to the first, 1x to the first, so that's great. So we have -1 up front. Then we're going to do our coefficients. 3x cubed, -2x squared, +2x, and -5. As you can see, I wasn't missing a term, so I didn't need to add in that 0. Okay, remember in the next step, bring down that first term, that first number, so I got 3. Then we multiply. -1 times 3 is -3. Then what do? We add. -2 plus -3 is -5. Multiply. -1 times -5 is 5. 2 plus 5 is 7. 7 times -1 is -7. Add straight down, we get negative 12. Again, I'm going to go through this process. Remember, remainder, constant, x squared. My other clue to you is whatever this exponent is, so the highest exponent, this one will be the next one down. Okay, so my answer is going to be 3x squared minus 5x plus 7 plus remainder, which is negative 12, over our divisor, which in this case is x plus 1. Yay? Okay, guys, let's move on. We have the remainder theorem. So what good is the remainder theorem? The remainder theorem allows us to know if it's going to be a factor or not, or what the remainder is. So if you only care about if it's a factor, or if you only care about the remainder, all you have to do is plug in f of k. So just like we did in 3.1, evaluate what it is. Okay, so this is what I'm going to say to you. So down here, what we're going to do is I'm going to evaluate to show you what the remainder is, and then we are going to use synthetic division. Okay, I know this is, so I'm actually going to substitute right here. So I'm going to say f of k, and k is going to be this negative 4. Okay. Now remember, this is in different form. This was x minus k, this is x equals. So that's why I don't use the opposite, so be very careful. Okay, so I'm going to go 5 times negative 4 cubed minus negative 4 squared plus 13 times negative 4 plus 29. Now right now I want you in your calculator to do that. If you need pause, do it right now, but I will give it to you. And no, I'm not doing this in my head. I get negative 359. Okay, so that should be the remainder. If it was 0, it'd be like, hey, there's no remainder, so it is a factor. But right now, this has a remainder. So I'm going to prove that to you as we go through synthetic. Okay, so remember, bring 5 down, multiply, get negative 20, add, we get negative 21, multiply, we get 84, add, we get 97. Oh, this is getting big. Now we go negative 4 times 97, we get negative 388. Add straight down, and what do we get? What do you know? We got the negative 359. Woo! So if all it wants is the remainder, you do not have to do synthetic division. All you have to do is evaluate at k. So make sure when you guys do this on your homework, if it says use synthetic to evaluate, all you need to do is evaluate at that k. All I want is that remainder. All right, this might take some time, and it's going to take a lot of little mistakes, guys, and that's okay. Division is kind of that top level operation. So make sure you take your time, and you might see that your mistakes could be you're adding, subtracting, little things. So if you are confused, make sure to ask questions. All right, thanks, guys.